Hey, what's up, guys? I hope you guys are ready to rumble with another section of electrocardiography. What I wanted to cover today is going to be intervals and segments and defining those properly, both of which are going to tell us and help us identify little events that are going to be happening on the heart and overall giving us a picture of the heart of the patient's heart condition. Okay, so let's go ahead and start with one particular term here. It's called, if you look, okay, you see two segments that are being defined there. And I want to go ahead and define, first of all, what a segment is. So I'm going to zoom in, okay? I'm going to write it over here. So a segment is going to be a line between two waveforms. Between two. Okay, probably better defined as a flat line between two waveforms, because that's what we're seeing here. Okay, so look at the first one. This is a PR segment. This segment from here to here is in between the P wave and the Q wave, these two waveforms. Now, for this particular segment, this PR segment, this is telling us that in this moment in time, remember back, it's the x-axis, in this moment in time, there's nothing happening. The electricity isn't going forward, it's being held, okay, somewhere. So the PR segment is basically this line between the P wave and the Q wave. If we look at it physiologically, it's the period in time where the AV node starts to kind of get a hold of it and delays it there for a second before it goes down into that Q wave. All right, which is extremely vital for us to have that delay there in order for us to effectively pump blood and keep it moving forward. So that's our PR segment. Okay, now let's go to the next one. This is going to be my ST segment. And I'm actually going to switch pointers here. So this is, since we've already defined the ST segment, oops, I'm sorry, guys. This being my ST segment, okay? The ST segment is going to represent a kind of an early period of ventricular repolarization for both right and left ventricles, okay? That's all it's saying, is there's no electricity, but it's the early form of repolarization. And the ST segment is found between the end of the S and the beginning of the T wave. Now, this segment is huge, not more important than the PR segment, but it's fairly huge, because as you'll see later on in the course, this ST segment and being able to identify what is normal and its normal placement is going to be vital in finding things like injury, ischemia, and infarction. Okay, why? Because at the place where the QRS and the ST segment meet is the little area called the J point. So I'm pointing to it right there. That is my J point. And that J point is going to tell me whether there is any ischemia or is any injury or infarction on the heart. Okay? So what I mean is that this J point, with the presence of ischemia, will actually start to be what they call depressed, meaning that the J point will actually happen here, and the S wave only rises to about there and starts to form the T wave. Okay? On the other side of the scale, you could also have ST segment elevation, where the S wave rises above its average baseline, so it happens up here, and then starts forming the ST segment and the J point over there. Okay, so that's ST segment elevation. I don't want to get too far into it here, but do expect it in a future video. Okay. Now, one other thing that's going to help us identify how to gauge the J point and whether it's depressed or whether it's elevated is going to be the TP segment. You're not going to see the TP segment here, but basically the TP segment is going to be the segment that's formed by the T and the P flat line that's leading between both. Okay, so this flat line, you have the T wave, and then the flat line, and then we should have another P if we're looking at a continuous strip. Okay, so this TP segment is going to be another segment that we have there, and it's typically used to help give us a baseline measurement or a guidance to see whether the J point is actually elevated or depressed. So that's our third segment. We have the PR segment, the ST segment, and the TP segment, okay, in between. PR segment is going to be that delay in conduction of the electricity that we have from the AV node right before it enters the ventricles. The ST segment is going to be the period of early repolarization for both ventricles, and the TP segment is where we have this diastolic phase where there's no contraction going on, but it's a good baseline measure to help us see whether the J point is depressed or elevated. Okay, so those are my segments. Now remember their definition. They're simply lines between two waveforms, two flat lines, because they're usually isoelectric. Okay, now let's go to the next ones. I have intervals here being defined. So first I have a PR interval. Let's identify what a PR interval is going to mean for us. So again, I'm going to zoom in. Okay, I'm going to write it here. So an interval is basically a waveform and a line. Okay, that's what a wave or an interval is going to mean for us. A wave and a line. Now, the x-axis telling us about time. Okay, the PR interval for us is huge, massive to know and be able to identify, because this PR interval shows us the total amount of time that the signal took to travel from the moment that the SI node sparked it and shot it out through the atria to the moment that it finally got to the AV node and he held it there for a second right before it hit into the ventricles. Okay, so it's the total travel time of the atrial conductive, the electrical impulse traveling through the atria. From SA node, rises up, forms a P wave, gets stopped at the AV node for a certain amount of time, and that's our PR interval right before we go into the QRS. Okay, so that's one. It is a waveform, which is from the P, and our line coming together to give us that total travel time of electrical impulse. Okay, the next interval that you see here is going to be the QT interval. The QT interval is going to be now the total travel time, the total action time of ventricular response to that electrical impulse. So now, as the electrical impulse enters the ventricles, we form the Q wave, shoot up into the R wave, and then form the S wave and end meeting at the ST segment, or at what we'll call baseline. Okay, so all of that time from here, from the QRS meaning ventricular depolarization, through the T wave meaning ventricular repolarization, from here to here, all of that is the QT interval, the total ventricular time for depolarization and repolarization to occur. All right, so those are going to be our intervals and our segments, guys. We're going to be measuring those and looking at deviations like abnormal ST segments, prolonged PR intervals, prolonged QTs, or short QT intervals. All right, so remember these because they are huge things to know. Have a great day.